Hello everyone, hope all of you are fine. We are going to start our class very soon. Today our class is going to be about numericals in electricity. Very important concept for your science exam. Definitely from electricity chapter you are going to get numerical problems in your final exam. They may be for long answer type, case study or any 2 marks or 3 marks. Now today I am going to tell you about in electricity resistors. When resistors are connected in series or parallel, how numerical problems are going to be related to the series and parallel connection of resistors. We'll wait for a few more minutes. Only within few minutes we'll start our class. Okay. Hope every one of you are ready to listen today's class. Good evening, Ashrit. Deepak, good evening. Are you all ready? Inform your friends or share. Let's start today's class. Electricity numericals. So today we are going to know first we are going to learn what is the formula to find out effective resistance when resistors are connected in series or parallel. Hope all of you know that formula, but now first I will tell you what is the derivation, how to derive that formula. So here one very important point you have to remember: when resistors are connected in series, there will be only one single path to pass the current. So by this we should understand there will be single current. Current is not divided, current is same across all the devices when devices are connected in series. So in this figure you can see there are three resistors, R1, R2, R3, and all the three resistors are connected in series. So current across R1, resistor R1 is I, current across R2 also I, current across R3 also I. There is no change in current across three resistors R1, R2, R3. But when you talk about voltage, that is potential difference will be divided in series. This is one very important point. In series connection, current across all the resistors is same, but potential difference across all the devices will be divided. Because three devices are there, the whole potential difference, total potential difference will be divided as V1, that is V1 across R1, V2 across R2, and V3 across R3. So in series connection, potential difference will be divided as V1, V2, V3, V4, how many devices are there? Those many parts it will be divided, potential difference. But whereas current is same through all the devices. So this is one very important point we have to remember. So here now potential difference is divided in this figure. Potential difference is divided as V1, V2, V3. So the whole potential difference across the circuit will be equal to V is equal to V1 plus V2 plus V3. So potential difference is equal to sum of all the potential differences across the devices. V is equal to V1 plus V2 plus V3. Hope you understood this. Now we use Ohm's law formula. According to Ohm's law, potential difference is directly proportional to current. Potential difference is directly proportional to current. So V is equal to IR. Hope all of you remember this formula. So what it is? V is equal to IR. So total potential difference is equal to total current into total resistance of the circuit. V is equal to IR. Not only this, even at V1 also, V1 is equal to current is same I only, but resistance is R1. At first resistance is R1. Now second, V2 is equal to current is same I, but resistance is R2. Next, similarly V3 is equal to I is same, but resistance is R3. So these values we will substitute in the given thing. So what happens? IR is equal to V1 means IR1 plus IR2 plus IR3. Now in all the terms we have I common, so we will take I common. So we get I is equal I into R1 plus R2 plus R3. So here it is IR. On both the sides we can cancel I. Now effective resistance is going to be R is equal to R1 plus R2 plus R3. So this is going to be the formula when resistors are connected in series. Hope you understood this. So this is the formula when resistors are connected in series. R is equal to R1 plus R2 plus R3. This formula we are going to use in next coming problems when we solve these problems. Hope this is okay. You understood this one. And this derivation and formula, you know, most of you know all this formula. All of you know this formula. Now I am going to tell you what is the formula when resistors are connected in parallel. When resistors are connected in parallel, you know what happens when resistors are connected in parallel? When resistors are connected in parallel, like before only, again, in this case, current will be divided, but potential difference is same. Current is divided, but potential difference is same. So here in the figure, you can observe there are three resistors R1, R2, R3. Three resistors R1, R2, R3. So I will be divided. Current I will be divided as I1, I2, I3. But here what happens? Potential difference will be same. Potential difference across all the three resistors is same V. So now because I is divided, we write I is equal to, in this case what happens? In this case we write I is equal to I1 plus I2 plus I3. I is equal to I1 plus I2 plus I3. So now again we know the formula V is equal to IR. V is equal to IR. From this what is I? I is equal to V by R. I is equal to V by R. So when I is equal to V by R, I1 will be equal to V by R1. I2 will be equal to V by R2 and I3 is equal to V by R3. So now these values V by R1, V by R2, V by R3 we will substitute in the formula so that we get V by R is equal to V by R1 plus V by R2 plus V by R3. So in this case what we can take common? In this case we can take V common, so that if you take V common, V by R is equal to, if you take V out, there will be 1 by R1 plus 1 by R2 plus 1 by R3 left. So now what we can cancel on both the sides like before? Now we can cancel VV on both the sides, so that we get 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is what resistance formula, effective resistance when resistors are connected in parallel. Hope you understood now what are the formulas when resistors are connected in series or when resistors are connected in parallel. So by using this formula and previous formula, we are going to find out solutions for numerical problems. Okay, now let's see how are the problems based on these. So first question. This is first problem. What is the highest? First one we have to find out highest resistance, and the second one we have to find lowest total resistance that can be secured by the combinations of 4 coils of resistors, 4 ohms, 8 ohms, 12 ohms and 24 ohms. Can you find out what is the effective resistance, effective total resistance? What can be total resistance that we can obtain from these 4 resistors? How can we find out total resistance when these, by using these 4 resistors? First tell me what should be done when you want the resistance of highest. When you want highest resistance, how resistor should be connected? When you want highest resistance, how resistor should be connected? When you want lowest resistance, how resistor should be connected? You can respond in the chat. Do you have idea? You have given 4 resistors, 4, 8, 12, 24. Ashrit, good, correct. So when you want highest resistance, we have to connect all the 4 resistors in series connection. So when you connect all these 4 resistors in series connection, what will be the total resistance? Yes, Ashrit is correct. When you want highest resistance, they should be connected in series. When you want lowest resistance, you should connect all those in parallel. In this case, when you want highest resistance, you have to connect them in series, and in series effective resistance is equal to sum of all individual resistances. Harshit, okay. Okay, Harshit is correct. Harshit is correct, okay. So when you want highest resistance, all these resistors should be connected in series. So when you connect these in series, the formula is going to be R is equal to R1 plus R2 plus R3 plus R4. 4 resistors are connected. And that is 4 plus 8 plus 12 plus 24. What is the total highest resistance when they are connected in series? Did you get it? Smaran, you are late today. Good evening. 12 plus 12, 24 plus 12, 48 ohms. Very good, Deepak. 48 ohms is highest resistance that can be obtained by using given 4 resistors. 48 ohms is the highest. Now what is the lowest? Lowest also you answered, Deepak. That is 4 ohms. Let's see how do we get lowest resistance. When you want lowest resistance, you have to connect all these resistors in parallel. When you connect all these resistors in parallel, what happens? Formula is 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. So by this 1 by R is equal to 1 by 4 plus 1 by 8 plus 1 by 12 plus 1 by 24. So here how do we simplify? We have to take LCM for all these. LCM of 4, 8, 12, 24 is 24. So we write 24 here. So to get 24, we have to multiply 6 to 4. So we get 6 plus 8 3s are 24. So 3 plus 12 2s are 24. So 12 2 plus 1. So what it is? 6 plus 3 9. 9 plus 1 9 plus 2 11 plus 1 12. So it is going to be 12 by 24. After cancellation it is 1 by 2. So 1 by R is equal to 1 by 2. Therefore R is equal to 2 ohms. So when you connect them in parallel, we get 2 ohms. So the lowest resistance is going to be 2 ohms and highest resistance is going to be 12 ohms. So this is 1 second. This is lowest resistance and this is highest resistance. Hope you understood this problem. Deepak, it's not 4 ohms, it is 2 ohms. Right, shall we do another one now? Next problem. This is one simple problem, but next problems are going to be like your long answer type board questions, like 4 marks and 5 marks. Are you all ready for the next one? For 4 or 5 marks. Next question is going to be like this. Read the question, understand, and you can find out. If you know how to do, you can find out that solution also. Okay, first question is what? We have to find out the total voltage in the circuit. How can we find out total potential difference in the circuit? What is the total potential difference in the circuit? First question, find the battery voltage. Determine the battery voltage. First one, we have to find out battery voltage. So to find out battery voltage, what we have to find out in this? See, read question completely. We have it last. At last it is given that potential difference across R1 is 5 volts. Potential difference across R2 is 2 volts. Potential difference across R3 is 6 volts. So we have to find out what is the battery voltage, total voltage. Do you know what to do here? Deepak, answer is R1 plus R2 plus R3. I by R1 plus R2 plus R3. But see here we have already know V1, V2, V3. In question it is mentioned what is V1, V2, V3. See here, this is V1 5 volts, V2 2 volts, V3 6 volts. So here V1 5 volts we already know, V2 2 volts already we know, V3 6 volts already we know. They are asking to find total voltage because all these are connected in series. V is equal to V1 plus V2 plus V3. V is equal to V1 plus V2 plus V3. So V is equal to V1 is 5, 5 plus 2 plus 6. So V is equal to 5 plus 2 7, 7 plus 6 13 volts. This is the first question answer. First question answer is what? 13 volts. Hope you understood how we get that first one. Is it clear first one? Now let's see second one how to do. Second question is we have to find total resistance of the circuit. Can you give me an idea how to find total resistance of the circuit? How can we find total resistance? Total resistance we can find out. You know, V is equal to IR we know. V is equal to IR we know, but we want R here. So when you want R is equal to V1 by R is equal to V by I. R is equal to V by I we know. Similarly, R1 is equal to V by I1. Remember, R1 is equal to V1 by I because I is same. I is same everywhere. So V1 by I1. I total resistance. V1 by I and that V1 is what? 5 volt. 5 by current is what? 4 amperes. 5 by 4. So R1 is equal to 5 by 4. Hope you understood this. 5 by 4. So that is 4 ones are 4, 1 will be left. So 4 twos are 4 fives are. So what it is, 1.25 amperes ohms, because it is resistance 1.25 ohms. Now R2 is equal to V2 by I1. V2 by I. R2 is equal to V2 by I. So V2 is what? 2 volts and current is 4. Same. Current across all the resistors is same. So V2 by I. So it is 2 by 4. 2 by 4 is 1 by 2. 1 by 2 is 0.5. 0.5 ohms. Correct? Now R3. R3 is equal to V3 by I. We know V3 is 6. 6 by 4. 6 by 4. 6 by 4 is how much? 3 by 2. 3 by 2 is 1.5. So like this we can find out R1, R2, R3. Now, second question is total resistance we have to find. Last question is all the individual resistances. Okay, now here we got third one. So second one how to find? Second one we can add all these R is equal to R1 plus R2 plus R3, or we have another way, R is equal to V by I. We wrote here formula R is equal to V by I. Total voltage we know 13. Total current we know 4. 13 by 4. If you divide this 13 by 4, 4 3s are 12. So it's going to be 4 3s are 12. Point 1 will be left. So 4 2s are again 4 5s are. So 3.25 ohms. Now you can check your final answer correct or not. How can we check our final answer correct or not? See, when you add all these three resistors, you have to get this 3.25 ohms. Check it once. What happens? 0.5 plus 1.5. 2 plus 1.25. 1.5, 0.5, 2 plus 1.25, 3.25. So total resistance also 3.25. So R is equal to R1 plus R2 plus R3 we got. This is the way we can find out total voltage and individual resistances R1, R2, R3. We can find out this total resistance in two ways now. I told you V by I directly, or you can just add R1 plus R2 plus R3, then also you will get total resistance. Hope you understood this, everyone. Clear? Shall we move to the next one now? Okay, now the next one. Next question is, see, now this is the next one. You can read question properly and try to understand. Try to answer this question. Potential difference. First question, what we have to find? Determine the potential difference across R3. First question. Here total resistance is given 100 ohms. Total resistance is given 100 ohms. Determine the current flowing through resistor R1. We should also find the resistance R2, that is resistance across R2, that is resistor R2. Can anyone answer what is the first question? Answer. What is the potential difference across R3? What is the potential difference across R3? It's very simple. In series connection, potential difference is divided. So when potential difference is divided, what happens? V is equal to what? V is equal to V1 plus V2 plus V3. Deepak got correct answer. Lean also got correct answer. That okay, 11 volts. Correct. Because see, voltage across R1, that is potential difference across R1, it is given 10 volts. Potential difference across R2 is given 4 volts. And the total potential difference is given 25 volts. So potential difference across R3 should be 11. So here what we use formula, we know V is equal to V1 plus V2 plus V3. We know V as 25, that is equal to 10 plus 4 plus V3. So therefore V3 is equal to 25 minus 14. So V3 is equal to 11 volts. So your answer is correct. Second question answer. Second question answer. Oh, Deepak got all the two answers also. Second question answer. Determine the current through resistor R1. Current through R1. Current through R1. How can we find current across R1? Deepak answered it as 0.25. Current across R1, how can we find? Here again you have to remember the formula. One very important point, that is current in series, it is same. Current across R1, current across R2, current across R3, all the three it is same. So when you want current across R1, that is nothing but same current across R2 and R3 also, total current. So here we know total potential difference and total resistance. So current is equal to formula by Ohm's law. Ohm's law formula, current I is equal to what? V by R. V by R, total resistance. So we know I is equal to total voltage is 25 volts and the total resistance is 100 ohms. So it is what? 1 by 4. 1 by 4 is how much? 0.25 amperes. This is current across whole circuit, because in series connection there will be same current across all the three. So here it is I, here also it is I, here also it is I. So it is 0.25 amperes across all the three resistors. Hope you understood this. 0.25 amperes. So this is first question answer. This is second question answer. What is third question answer? We have to find resistance across R2. We have to find R2. What is R2? Here one Deepak answered what is R2. But do you know other students how to find R2 here? Again we use same formula, that is Ohm's law. We know V is equal to IR, but it is V is equal to V2 is equal to IR2. We have to use V2 is equal to IR2. By using this formula, V2 is equal to IR2, R2 is equal to V2 by I. R2 is equal to V2 by I. So what is V2 here? 4 volts by what is I here? 0.25 amperes. 0.25 amperes. So we can also write it as 400 by 25. 400 by 25. 4 by 0.25, which is 400 by 25. So if you cancel this now, 5 5 is 25. 5 8s are 40, 0. So again 5 1s are 5, 16s are, so what it is 16 ohms. So R2 is equal to 16 ohms, and I total current is equal to 0.25 amperes. So hope you understood all this. Is this problem clear? Clear? Shall we go to the next one now? So in this way we can find out any voltage, any current or any resistance. You have to know in which case voltage is divided, in which case current is divided, how to use Ohm's law according to the question. Now next question, see this is our next question. So here it's given that 12-volt battery is connected in a circuit having three resistors, three series, having three series connected in resistors, that is resistors are connected in series having resistances 4 ohms, 9 ohms, 11 ohms. Determine the current flowing through and the potential difference across 9 ohms. So we have to find out what is current through 9 ohms and potential difference across 9 ohms. Can you try? Once try this. First question, you have to find, determine the current through the circuit, because current through 4 ohms, 9 ohms, 11 ohms, everything it is same. So total current we have to find, and also potential difference across 9 volts, 9 ohms also we have to find. So can you find out what is current first? Current answer, did you get anyone? What is the current through the circuit here? Current across the circuit. So no answer came till now. So I am explaining what is, how to find out this. So here we have to find out total resistance first. So because all resistors are connected in series, so effective resistance is going to be R is equal to R1 plus R2 plus R3. Then what is R? R is equal to 4 plus 9 plus 11. So R is going to be 24 ohms. So this is what total resistance. Total resistance we got. Next, we have to find total current. So total current, how we can find? By using Ohm's law. We know V is equal to IR. From this we want I value, what it is. I is equal to V by R. I is equal to V by R. So here we get I is equal to V is 12 and R is 24. 12 by 24 is exactly 1 by 2, which is 0.54 amperes. 0.5 amperes. So we got total current. Total current is 0.5 amperes. Total current is 0.5 amperes. Hope you understood this. Total current we got, total resistance we got. Now we can find out potential difference across 9 ohms. So there it is given it as V1. So V1 is equal to I into R. V is equal to I into R. So here it is I is 0.5 amperes across every resistance, 0.5 amperes only, and resistance is 9 ohms because we want voltage across 9 ohms. So total current 0.5 amperes we have to take, and it should be multiplied by 9 ohms, which is 4.5 volts. It is 4.5 volts. So this is across 9 ohms. Similarly, you can also find voltage across 4 ohms also. What is voltage across 4 volts? 4 ohms. It is 4 into 0.5. So if you take that, okay, let's take it as V2. In question it is given V1, but if you take it as V2, what is V1? V1 is equal to 0.5 into 4, which is 2 volts, and V3 is equal to 0.5 into 11, which is 5.5. So once add 5.5, 4.5 and 2, you will get total again 12 volts. So V is equal to V1 plus V2 plus V3 is verified. Hope you understood. But here question is about to find out only potential difference across 9 ohms. Potential difference across 9 ohms is 4.5 volts. Hope you understood this. So total current is 0.5 amperes. Voltage across 4 ohms is 2 volts. Here 4.5 volts. Here 5.5 volts. And total current is 0.5 amperes. Now next question. Shall we move to the next question now? Next question is this. See what is this question? Try. You have to find out potential difference in this. Potential, find the voltage V in the given figure. You may have doubt that already V is given 50 volts. Then again why we have to find V? Namaste. Again why we have to find out V, you know. There that is voltage across 6 ohms. There that V is between, you know, terminals of 6 ohms. So you have to find out potential difference across 6 ohms. So total potential difference is 50 volts, but here we have to find potential difference across only 6 ohms. How do you find? Write once, some like same previous concept. It's connected to another battery. No, it's not connected to another battery. That is a voltmeter there, Lina. Lina, that is a voltmeter connected across 6 ohms. So this 50 volts is divided across 4 ohms and 6 ohms. So now like before we did, what is the potential difference across 4 ohms? Like 9 ohms, and one more also 11 volts, 11 ohms. So it is divided. Similarly here also this 50 volts will be divided at 4 ohms and 6 ohms. What is the potential difference across 4 ohms? What is the potential difference across 6 ohms? Here they are asking only potential difference across 6 ohms. It's not another battery. Same battery, you have to find out what is the potential difference across 6 ohms. So got idea what to do, how to find? Now tell me first how these 4 ohms and 6 ohms are connected. How these 4 ohms and 6 ohms are connected? Are they in parallel or series? 2.4 is not correct. Who is this? Pramod. 2.4 ohms is not correct. No, they are not in parallel, Pramod. If they are in parallel, the voltage will be same. In parallel connection, potential difference will be same. Potential difference is not divided. 50 ohms only it will be. They are not in parallel there. 4 ohms and 6 ohms are not in parallel. 4 ohms and 6 ohms are in series. 4 ohms and 6 ohms. Both the resistors are in series only. Yeah, correct. Oh, Smaran. They are in series. Why you confused? Because it is one is in horizontal way, one is in vertical way. You confused. They are in series or parallel. See, here there is no other device this side. So they are connected in series only. Okay. I will draw this again to understand better. It is like this. 4 ohms. Again 6 ohms here. You do not have any other device here, right? So this is what a potential voltmeter here. Voltmeter is connected there. So what? These two are connected in series only. This one and this one both are connected in series only. So now these two are connected in series. So like before we can find out total resistance what it is. Or you can find out directly. You want potential difference across 6 ohms. So what formula? V is equal to total potential difference is equal to 50. And let us take R1 as 4 ohms and R2 as 6 ohms. We want V2. V2 means what? I into R2. V2 is I into R2, but we do not know I. So first what we have to do? We have to find out I what it is first. We have to find what is I. To find out what is I, we have to find out effective resistance first. Effective resistance is what? R1 plus R2. That is 4 plus 6, which is 10 ohms. Now total current we can find. Total current is what? V by R. V by R. V is what? 50. Total voltage 50 and R is 10. So 50 by 10, 5 amperes. Total current is 5 amperes. Same like before, we got 0.5 amperes before. What is 10 there? Why you got 10? So I is equal to 5 amperes. When I is equal to 5 amperes, we want V2. V2 is what? I into R2. I is what? 5 and R2 is what? 6. So 5 into 6, 30 volts. So potential difference across 6 ohms is 30 volts. Here it is 30 volts. So what is V1? Can anyone tell me what is V1 then? Potential difference across 4 ohms is what? What is potential difference across 4 ohms now? R is 10. Okay. Okay, good. R is 10. I is 5. Correct. So now tell me potential difference across 4 ohms. Same method like I R1, I into R1. I into R1 means what? 5 into 4, 20 volts. So this 50 volts is divided as 20 volts and 30 volts. 20 volts across 4 ohms, 30 volts across 6 ohms. Hope you understood this. So don't confuse how they are connected in series or parallel. They are in series here. Now let's move to the another problem. Now this is your next problem. See how these resistors are connected here. How these resistors are connected in this connection in this problem. Correct? Is it Smaran? Pramod? Parallel. This is correct. Here there is no doubt. All the three resistors are connected in parallel. Good. Okay, they are connected in parallel. But now what is the question? First question. Find the reading ammeter. Yes, Lena, correct, parallel. So now we have to find out the reading across ammeter across R3. So current across R3 we have to find one thing. Current across R3 we have to find. Okay, Smaran. Current across R3 we have to find, and as well as potential difference across R2 we have to find. How can we find current across R3? That is 20 ohms. Oh, Ashrit. Ashrit is there, Smaran is there. Okay. Now try it. In this question, you have to find current across R3. Total current is given 11 amperes. You can see the figure clearly. Total current is 11 amperes, and current across R1 it is given. So you have to observe figure carefully. In this, shall I zoom it? Now you can see better, I think. So here I1 current, total current will be divided into three parts. That is, total I is divided as I1, I2, I3, three parts. So I took in wrong way, reverse way. So that is first one here I1 because R1 is given there. This is I2 here. This is I3, and this is total current I. Okay. Now by using this 8 amperes and R1 is equal to 5 ohms, we can find out potential difference here. What is the potential difference formula? V is equal to IR. V is equal to IR, but here V1 is equal to I1 R1. V1 is equal to, okay, here one more thing we have to remember, that is in parallel connection potential difference is same. In parallel connection potential difference is same. So V is equal to I1 R1. So V is equal to 8 into 5. 8 into 5. Yeah, Smaran is correct. V is equal to 40 ohms or 40 volts. V is equal to 40 volts, and this 40 volts is same across all the three resistors because all the three are connected in parallel. So here it is 40 volts. So here also it is 40 volts. So here also it is 40 volts. Did you understand this? Because all the three are connected in parallel, potential difference is same, 40 volts, 40 volts, 40 volts. Now we got potential difference across every resistance. Now reading of ammeter we have to find, means what, this value what it is we have to find. I3 we have to find. I3 is equal to V by R3 now. By Ohm's law only, I3 is equal to V by R3. We know what is V. V is 40 volts, and R3 is what, 20 ohms. 20 ohms. So now what it will be, 2 amperes. I3 is what, 2 amperes. Current across resistance 3 R3 is 2 amperes. Hope you understood this. This is 2 amperes. Now we have to find the resistance R2. We have to find resistance R2. Okay. How can we find resistance R2? See here, total current we know. Total current I is equal to 11. Okay. We also know I1 is equal to 8 amperes. Now we got I3 is equal to 2 amperes. Now can you tell me what is I2 value? What is I2? Total is 11 amperes. I1 is 8 amperes. I3 is 2 amperes. And what is I2 now? I2. Okay, see here. In parallel connection, I is equal to, in parallel connection, I is equal to I1 plus I2 plus, correct. Smaran is correct. I1 plus I2 plus I3. So here we know 11 is equal to, Ashrit Leena is also correct. 11 is equal to 8 plus 8 plus I2 plus 2. Therefore, we got I2 is equal to 1 ampere. I2 is equal to 1 ampere. When I2 is 1 ampere, can we find out what is R2? Can we find out what is R2 now? R2. What is R2? How can we find? Okay, I will explain. R2 is equal to V by I2. R2 is equal to V by I2. V is 40 volts by I2 is 1 ampere. So 40 by 1, 40 by 1 is 40 ohms. So R2 is equal to 40 ohms. Did you understand this? 20 ohms. Huh? How it is 20 ohms? Smaran? Current is 1 ampere only. When current is 1 ampere, formula is V by I. V by I1. R2 is equal to V by I2. I2 is 1 ampere. When I2 is 1 ampere, 40 by 1. 40 by 1 is 40 ohms only. Is it clear? Did you understand? So it is 40 ohms. So now first question we got V what it is. Second question we have to find total current. What is I1? What is I2? What is I2 we got? After we are finding I2 we got R2 what it is. Okay. Now next problem. See this problem. Oh, this problem. This is our last problem. Of this remaining problems in the next class. Okay. Now how to find these values? First one, find the supply current. We have to find out total current in this. Total current we have to find out. How can we find total current in this? To find out total current, you have to find out total resistance first. Total resistance. Can you find out total resistance here? Do you know how to find total resistance? See how these two are connected. First you have to find out effective resistance of these two. 6 ohms and 2 ohms. That 6 ohms and 2 ohms are connected in. How they two are connected? 6 ohms and 2 ohms. R2 and R3 are connected in parallel. So effective resistance of R2 and R3 we have to find out first. So effective of R2 and 3, I am taking R2 3, that is 1 by R2. 1 second. I am taking it as 1 by R2 3. That is effective resistance of R2 and R3 is 1 by R2 plus 1 by R3. That is equal to 1 by 6 plus 1 by 2. So after taking LCM, 1 by 6 plus LCM is 6. Here 3 should be multiplied, 3 by 6, which is 4 by 6. So R23 is equal to 6 by 4, 3 by 2. 3 by 2 is how much? 3 by 2 is 1.5. 1.5 ohms. Now like this it will be. This is 2.5 and between this is effective resistance 1.5 and this is 4. Now how these three are connected? How these three resistors are connected now? Series. Because these three are connected in series, what is the effective resistance? R 2.5 plus 1.5 plus 4. Oh, you got answer also, Deepak. Correct. But now here the effective resistance is 8 ohms. R we got 8 ohms. Once you know R, you can find out what is I. I is equal to V by R. That is 200 by 8. So 8 ones are 8 twos are 16. 4012, 4040, 8 fives are 40. Therefore, current is I is equal to 25 amperes. Hope you understood effective total supply current, what it is, how to find. Hope you understood now. Now we have to find, after this we have to find current flowing through each resistance. How can we find current flowing through each resistance? Okay, so this one I'll explain. Lena 25 amperes. Okay, now we have to find out. So first we can find out current through 2.5, 1.5 and 4. Because all the three are connected in series, the same current will flow through R1, 2.5, 1.5 and 4 ohms. So here total voltage, potential difference we know, total resistance we know. I is equal to V by R. We know I is equal to V by R, but we want R. R we already got. I we want V by R. So V is what? 200 by R is what? 8. Oh, 1 second. So total current we already got 25 amperes. So here you should understand one thing. So current across R1 will be 25 amperes only, and current across 4 ohms also 25 amperes only, because these two are connected in series. Now we have to find out current across this 6 ohms and this 2 ohms, because they two are connected in parallel. Because they two are connected in parallel, we have to find out current across 6 ohms and 2 ohms. So here potential difference will be same. Here 200, not 200, it is not 200. 25 amperes is divided into two parts, I1, I2. Then we can find out here V1, V2, V3 what it is, what is potential difference, because in series connection potential difference is divided. So you can find out V1 across 2.5, V2 across 1.5, V3 across 4 ohms. Okay, now we can find out in this way. V1 is equal to I into R1, that is 200 into 2.5. Oh, not 200. One second. I is what here? I value is 25 amperes. 25 into 25 into resistance is what? 2.5. 25 into 2.5. How much? 25 into 2.5 is 62.5. 62.5 volts it is. Similarly, V2 is equal to I into R2. 25 into 1.5. 25 into 1.5, how much? 5 5 is a 25 to 125 and 25. That is 37.5. 37.5 volts. So V3 is equal to I into R3. 25 into 4, which is 100 ohms. So see, this 200 volts is divided as 62.5 volts, 37.5 volts and 100 volts. Now in the figure, see here it is 62.5 volts, here it is 100 volts, but across these two, because they two are connected in parallel, here 37.5 volts, here also 37.5 volts. So now if you want current across R2, current across R2, what? I2 is equal to V by R2. I2 is equal to, we have to find V by R2. So V is what? 37.5 by R2 is 6 ohms it is. So we have to cancel it. 6 6 are 36. Okay, if you keep point, it will become 15 now, because 1 will be remainder 15. So 6 2s are 12. 3 will be left. 6 5s are 30. 6.25 amperes it is. 6.25 amperes. So similarly, current across R3, that is 2 ohms, that is V by R3, that is 37.5 by 37.5 by, it is 2. So how much it will be? 2 ones are 2, 1 7 17, 2 eights are 16 point, it will become 15 now, 2 sevens are 14, 1 will be left, 2 fives are 10, 18.75 amperes. So in this way you can find out current across each resistance. So current across these two is 25 amperes only, but here it is 6.25 amperes and 18.75 amperes. So what is total current across this one now? It is again 25 amperes only. 25 amperes only. Once add these two, 6.25 and 18.75, once add both, you will get 25. Yeah, correct. Deepak, correct. So if you add both, we will get 25 only. This 25 amperes only divided into 6.25 and 18.75. So in this way, we last question is potential difference across each resistor. Already we got potential difference across each resistor is here 62.5, here 37.5, here also 37.5, and this is 100 volts. Third question answer. And this is second question answer. 25 amperes and 6.25 amperes, 18.75 amperes, and the last one again 25 amperes. Hope you understood all these solutions today's class. It will be, if you understand all this, definitely it will be useful to you in your board. Some compulsory, I have seen some previous year papers, in every paper either 5 marks or 4 marks case study questions are being given like this. So you practice this type of question, definitely you will get better marks. Hope this session will help you. Like this in future also, if we have time, we will discuss about maths and science related important concepts. Okay. Shall we leave today? Right. Thank you. See, try to join whenever I mention, try to join from starting, and definitely it will help you. Share your friends, tell them, ask them to join in time. Try to understand. Thank you.